everyone, welcome to my YouTube channel Self Study. Today we will continue the chapter number 6, heat energy. So in this chapter you will learn compare and contrast boiling and evaporation, describe thermal expansions of matter, describe linear area and volume expansion, compare expansivity in solid, liquid and gas, and so on. So let's continue the chapter. Introductions. In the earlier classes, you have read that matter is composed of tiny particles called the molecules. It means that you have learned that matter is composed of tiny particles called molecules. Molecules can exist freely in nature and it possesses the property of the matter. It is very small in size, nearly 10 to the power minus 10 meter, and cannot be seen even by the microscope. The molecules are in motions as well as they have the force of attractions amongst themselves. Means molecules are very small, so you cannot see even by microscopes, and they are in motions as well as they have force of attractions among themselves. Due to motions, the molecules have the kinetic energy, and due to force of attractions they have potential energy. It means due to motions, molecules have kinetic energy, and due to force of attractions, they have potential energy. The solid state would have the greatest potential energy and least kinetic energy. The gaseous state, on the other hand, would have the least potential energy and greatest kinetic energy because it move around, randomly move. When a substance absorbs heat, the motions of its molecules become rapid, so their kinetic energy increase. Means when a substance absorbs heat, it came in motions and their kinetic energy increase. When the substance is cooled, the motions of its molecules become slow, and so their kinetic energy decrease. And when it's cool, the motions of molecules become slow, and so their kinetic energy decrease. The total kinetic energy of molecules of a substance is called its internal kinetic energy, and the total potential energy of molecules is called its internal potential energy. The sum of internal kinetic energy and internal potential energy is called the total internal energy or heat energy of substance. Means the sum of total internal kinetic energy and internal potential energy is called total internal energy or heat energy of the substance. Thus, heat is internal energy of a substance. It is measured in the unit joule, symbol J. Okay, when two bodies at different temperatures are kept in contact, heat flow from a body at higher temperature to a body at lower temperatures. The average kinetic energy of substance is a measure of temperatures of the body. When there is a rise in temperatures, kinetic energy of molecules of a substance, its temperature increase, and if there is fall in the average kinetic energy of molecules of a substance, its temperature decrease. However, during the change in state of substance at a constant temperatures, there will be no change in the average kinetic energy of its molecules. Now, effect of heat. There are three effects of heat. Number 1, change in temperatures of the body, change in state of the body, and change in size of the body. Now, what is point number 1? Change in temperature of the body. When the body is heated, its temperature rise, and when it is cooled, its temperature falls. It's normally when body is heated, its temperature will increase, and when it is cooled, its temperature will decrease. The change in temperatures of the body depend on the following two factors. It also depends on two factors: quantity of heat impact to the body. When heat is imparted, quantity of imparted means when heat is imparted or given to a body, its temperatures rise. Means when you give heat to any body, its temperatures will automatically rise. While if heat is rejected or taken from body, its temperature falls. Means when you take heat from the body, temperatures will fall. Reasons: on heating, the molecules being to move faster, so the average kinetic energy of molecules increase. Means on heating, the average kinetic energy of molecules will increase, so temperatures rise. On the other hand, on cooling, the average kinetic energy of molecule decrease, so temperature falls. Number 2, material of the body. Some material rise to high temperatures while some at a low temperatures, even when some quantity of heat is imparted to them. Reason: different materials have different specific heat capacity. We know that every material have different heat capacity, different amount of heat required to rise the temperatures of unit mass by unit rise in temperatures. Point number 2, change in state of body. Matter exists in three different states, namely solid, liquid, gas. As you have already read about this, the process of change from one state to another at a constant temperature is called change of state. When a solid is heated, it changes into its liquid at a fixed temperature. Means when solid is heated, it changes into liquid at a fixed temperature. This process is called melting. The reverse happen when a liquid is cool. The liquid freeze into solid at the same fixed temperatures. This process is called freezing. For example, ice at 0 degrees Celsius on heating melt into water at 0 degrees Celsius. Means ice at 0 degrees Celsius on giving heat melt into water. It will melt into water at 0 degrees Celsius, while water at 0 degrees Celsius on cooling freeze into ice at 0 degrees Celsius. When a liquid is heated, it changes into its vapor. When liquid is heated, it changes into its vapor at a fixed temperature. This process is called vaporization or boiling. The reverse happens when vapor is cooled. The vapor condenses into liquid at the same fixed temperature. This process is called condensation. For example, water at 100 degrees Celsius on heating vaporizes into steam at 100 degrees Celsius, while steam at 100 degrees Celsius on cooling condenses into water at 100 degrees Celsius. You have already read at the previous chapters. When a solid on heating changes directly into its vapor at a fixed temperature, the process is called sublimation. Means when solid is heated directly into its vapor, its process is called sublimation. For example, camphor or heating change directly from solid to vapor. This vapors on cooling change directly into solid state. This process is called solidifications and depositions. The change of state from liquid to solid means the change of state from liquid to gas at all temperatures is called evaporations. Thus, evaporations differ from boiling. Evaporations and boiling is different things. Boiling is at fixed temperatures, while evaporations take place at all temperatures. Remember this, that boiling take place only at fixed temperatures and evaporation take place at all temperatures. For example, drying of clothes is due to evaporations of waters. Evaporation is a slow process, while boiling is a rapid process. This is the difference between evaporations and boiling. Figure 6.1 show the change in different state of matters. It is a figure change in states of matters. You have already learned about this. During the change of state, the heat absorbed means during a change of state, the heat absorbed or rejected is called latent heat or hidden heat because it is not manifested by any change in temperatures. This heat, when expressed for unit mass of a substance, is called specific latent heat. The latent heat, instead of rising the temperatures, is utilized to change the force of attractions between the molecules of a substance. Since temperatures remain constant, the absorbed or rejected heat has no effect on speed or the average kinetic energy of the molecules. Thus, during interconversions of state, the latent heat increases. Only the average potential energy of molecules, whereas the average kinetic energy remains unchanged. Now, third point, change in size of the body. When body is heated, it expands on and upon cooling it contrasts. It's normal, you have seen that when you give heat it will expand, and when upon cool it contrasts. This change in size of the body due to heating is called thermal expansion. Generally, all solid, liquid and gas expand on heating and contrast on cooling. The reason is that on heating a substance, the average intermolecular separations between the molecules of the substance increase, while on cooling it decreases. Means intermolecular separations between the molecules increase on heating, while on cooling it decrease. Effect of temperatures on molecular motions. Now, what is the effect of temperatures on molecular motions, we have read that molecules of each substance possess kinetic energy because they always move by virtue of their continuous motions. Because of the motions, when the motions become less rapid, the temperatures decrease, or if the temperature decreases, the molecules speed increase. At high temperatures, the molecules are very much agitated. This suggests that as a limit, when the temperatures will become zero, the molecular motions cease. The temperatures at which molecular motions completely cease is known as absolute zero or Kelvin scales. Means, what is Kelvin scales? Means temperatures at a molecular motions completely cease, means zero, is known as absolute zero. Temperatures lower than absolute zero is not possible. Change of liquid into vapor state. Change of liquid into vapor state in two ways. You can change liquid into vapor state in two ways: by evaporation at all temperatures and by boiling at a fixed temperatures. Now, evaporations, the change of liquid into vapors at all temperatures from its surface is called evaporations. Evaporation takes place at all temperatures, but boiling takes place at fixed temperatures. If you place a drop of ether on your palm, you will notice that the ether disappears within a few seconds and the palm feels cold. The process caused this phenomenon is known as evaporation. This is essentially a surface phenomenon. Evaporation is a surface phenomenon and take place at all temperatures. The process of evaporation can be understood in the term of molecular motions. Explanations of evaporations on the basics of molecular motions. It is difficult to break a solid into its small pieces, but a liquid can easily break up into small drops. It is difficult to break solid into small pieces, but liquid can easily be broken. We conclude, therefore, that the mutual force of attractions between the liquid molecules is much less than that in case of solid. The attractive force between the liquid molecules is not strong enough to keep them in fixed positions. Therefore, the liquid molecules can move throughout the liquid. Means liquid can move throughout the liquid. The molecules of a liquid on an average have a large speed than the molecules of a solid. The relative distance between the liquid molecules and the directions of their motions is found to be totally irregular. When molecules, while in motions, reach the surface of the liquid, means when molecules always in motions, means while in motions reach the surface of the liquid, it is pulled inside by the cohesion force. Means other liquid pull the upper surface liquid by the cohesion force of surrounding molecules of the liquid. As there are no molecules on the other side of the surface, thus the molecules are not allowed to leave the surface, and therefore a liquid has a definite volumes. And on the other hand, in a gas, the molecules are very much further apart than those of a solid or liquid. There is a very small or negligible force of attractions between the gas molecules, and therefore the molecules are free to move about over the either entire available space. Means gas are freely to move. This is why a gas have neither fixed shapes nor a fixed volume. In a liquid, molecules while in motions collide with each other. Some molecules which gain energy reach to the surface of liquid, while other which lose energy remain inside the liquid. Means which gain energy, means the molecules which gain energy reach to the liquid surface, and the molecules which lose energy remain inside the liquid surface. Thus the molecules on the surface of liquid have higher kinetic energy, means molecules on the surface have higher kinetic energy than those inside the liquid. During evaporation, the molecules on the surface which have sufficient kinetic energy to do work against the force of attractions on them due to other molecules inside the liquid escape out from the surface. Means the molecules which is at the surface, it escape out from the surface in a space. This escaping molecules from the vapor of a liquid, the process continues till all the liquid evaporate. The rate of evaporation depends on temperatures of liquid, wind, surface area, and the presence of humidity. So thank you for today. Please subscribe to my channel for the next part. Thank you.